In this video, we're going to look at Bernoulli trials and how they're created. So Bernoulli trials, there is a couple of things we need to know. There's the probability of success and the probability of failure. And these probabilities don't change throughout the question. So let's look at a simple example here. Let's say a family have 2 boys and 3 girls, and every morning the mother or father of the family, they pick their favorite child, or they put the 5 names in the hat, and the favorite child gets the biggest breakfast. So the probability of it being a boy is 2 out of 5. You can see there's 2 boys out of 5 children, which is 0.4, and the probability that the girl gets the biggest breakfast is 3 over 5, which is 0.6. So let's say the question is, so find the probability that they select a boy on Monday and a girl Tuesday to Friday. So we can see here a boy on Monday is 0.4, and a girl on Monday, which is actually this probability of it not being a boy, 0.6 to the power of 4 other days. Now what about, let's do this in the decimal first, it's 0.05184. But what if you were asked the question, what about if it was a boy one day and a girl on 4 days? A boy on 1 day and a girl on 4. So we can have boy, girl, 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 girl. We can have girl, boy, girl, girl, girl. We can have girl, girl, boy, girl, girl. We can have girl, 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 boy, girl. And the 4 girls could be Monday to Thursday, and the boy could be Friday. And you can see here that there are 5 boys on the 5 different days of the week, or there's 5 days to choose from, and we're choosing 1 boy. And I'm going to introduce the formula now for Bernoulli trials. I'll just write it in a different color. It's n choose or amount, and it's the probability, which is p to the power of 4, probability of not success, q, and because the 2 powers add up to n minus r, and we'll see how this works now with the boys up above. So I want 1 boy. The question is a boy on 1 day and a girl on 4 days. So there's 1 day that it's going to be a boy. The 5 choose 1 gives me the 5 boys, and it's the probability of success. Probability of success. And the probability of success for a boy is 0.4 to the power of, we want 1 of them, always this number here. And then it's multiplied by the probability of it not being a boy, which is obviously the probability of it being a girl, to the power of 5 minus 1, which is 4. And you can see here these 2 powers always add up to n, and this number here, the bottom number, is always the first power. And this is how we set up a Bernoulli trial. So the answer to this one, 5 choose 1 by 0.4 to the power 6 by 0.6 to the power 4, is the first multiplied by 5, which is 0.2592. Okay, a couple of 6 children. Find the probability of 4 girls and 2 boys. So we just now need to look at one as success and failure, and then just take it from there. So we 6 children. So let's look at the girls as successes. So the probability of a girl is a half, and the probability of a boy we will take as also a half. So we want 4 girls, so if we 6 children to choose from, 4 girls to choose from them, and the probability of a girl, the probability of success to the power of the bottom number, or by the probability of failure, and 4 and 2 is 6, which is 6 choose 4, same as 6 choose 2, so 6 by 5, 30 over 2, 15 times, well that'll be 1 over 2 to the power 6, which is 15 over 64. And we decimalize that, 0.23475. Okay, let's have a look at the probability that they have 5 girls and 1 boy. So they have 6 to choose from. They have to choose 5 girls. So we could do it as 1 over 2. 1 over 2 to the power of success by 1 over 2 to the power of failure. And 6 choose 5 is the same as 6 choose 1, which is 6 by, and again it's going to be 1 over 2 to the power of 6. So in this case, 6 over 64, which is equal to 0.09375.
Sir.
Okay, if we look at a question like this, 10% of people are left-footed, 11 players on a football team. Find the probability that less than 2 of them are left-footed. So the probability that less than 2 are left-footed is the probability of 1 or the probability of none. So we got to find both of these. So 10% are left-footed. So we'll call success left-footed. Probability of success is 0.1. So the probability of failure is 0.9. So we start with the first one. We want, out of the 11, we want one of them to be left-footed. So we're looking at success to the power of 1 by failure to the power of 10. And then for 0, we're looking at none of them to be chosen. So 0.1 to the power of 0 by 0.9. We want them all to be right-footed. And we're spotting this should be 11. All 11 of them, the whole team. So if I do these out and get my decimals, 0.384. And this one here on the calculator, 0.314 and 384. Sorry, that's 48. Just change, that's 348. 48 and 14. 0. Sorry, I'm jumbling them up. 84. 0.14. 84. 98. 698. We just rounded off for 0.7. Or as a percentage, 69.8% or 70% of the time you'll have a team where less than 2, just 1 or none of them are left-footed.